So when the copper reacted with the bromine, what was the color on the bromine? Orange, and then it disappeared. Okay. And then here, what did you guys get here? Blue what? Blue solution or blue precipitate? Blue solution. What did you guys predict? Which is a blue solution? Solid. Okay. How about this one? What did you guys predict for this one? No reaction? Oh. This one, there is a reaction here. Did you observe any reaction? Yeah, a precipitate formed. What was the identity of the precipitate? Bubbles of hydrogen gas should have formed, right? Which is a clear colorless gas. Well, the reason I brought up B and C is B and C are different than what you had predicted. You know, in B, we predicted a CuOH2 solid should have formed here. But you probably got a dark blue solution. Is that correct? Did anybody see a blue, light baby blue precipitate form? You did? Who else recorded the baby blue precipitate forming? And then what happened to the baby blue precipitate? It disappeared. Baby blue precipitate. And so those are important observations. In fact, this reminds me of the quote. You know that quote? I forgot the exact phrase, but it went something like chance favors the prepared mind, or the chance favors the... Well, you know, you come across things by chance, and you might not know if they're expected or unexpected. It's like the discovery of penicillin. You know, discovery of penicillin would have never happened if they didn't care that there was some unusual observation, right? But the person, unfortunately, the person washing the dishes or cleaning up knew that was an unusual observation, right? And so this is why we want to take keen observations. We want to take keen observations. We want to have some idea of what those observations should be like. But anyway, I didn't finish chapter 17, the reactions that we looked at. One of the reactions is lead-2 acetate, which is a CCS, clear colorless solution. It's actually a white solid. In fact, I wiped the bottle off, but you can see some solid. Do you see that on the neck there? It's when the water evaporates, it leaves behind lead-2 acetate solid. I'm wearing gloves because I don't want to touch it. And so the first reaction was lead-2 acetate with what? Sulfuric acid? Okay. So lead-2 acetate with sulfuric acid. Now, sulfuric acid is a common chemical. Since sulfuric acid is a common chemical, we don't really need to write down the color. We don't really need to write down the form of it. But this is sulfuric acid here. This is a clear colorless solution. And what did you predict? Lead-2 acetate plus sulfuric acid should form what? Should form a precipitate of lead-2 sulfate. Now what, this is colorless, this is colorless. What color do you think lead-2 sulfate is going to be? It's going to be colorless or white. Now the situation is, should I pour the acid here, or should I pour the lead into the acid? Well, if I'm going to pour the lead into the acid, I don't want to pour it in this bottle, so I'll pour the acid into a test tube. What should I do? Pour the acid or pour the lead? We always pour the acids. Have you ever heard double A? Double A's add acids, especially with sulfuric acid, because when sulfuric acid comes into contact with water, heat is generated. And so we want to add the sulfuric acid slowly, drop by drop. That way, water is a great heat sink. It'll absorb all that heat that's generated. And so it's always add acid. People who add water to acids run the risk of superheating the water and having that splatter and boil. on them. And so I'm going to go ahead and add the sulfuric acid, the lead. Let's see the color of the precipitate here. Actually, let's just do it here. And we got a white precipitate. It's a cloudy white PPT. Now the solution is going to be sulfuric acid plus lead 2. The solution is going to be acetic acid. Acetic acid is a CCS. So eventually the precipitate will settle down and leave us with a clear, colorless solution of acetic acid. Acetic acid should have a smell to it. It should smell like vinegar. And it does. It smells a little like vinegar. Here. It's very weak. Normally you waft the vapors to your nose because if you smell it directly, it can overpower. All right, what was the next reaction we did for 17 that we predicted? Actually, how many? I was thinking by now we should have it all done. Did you guys complete 17? Actually, how many people have completed 17? Okay, just two. You know what? I'm going to wait. I want you guys to predict it, and then I want to do it after you guys predict it. Okay? So I'm going to wait on this one, except for one reaction. The one reaction I want to show you is this. If I take lead-2 acetate and mix it with sodium hydroxide. So here's lead-2 acetate, which is my CCS. Then I'll take some sodium hydroxide. Here. Sodium hydroxide is also CCS. When it dries, pure sodium hydroxide is white solid. Right? And so I'll pour it in. What do you think is going to happen? Lead-2 acetate with sodium hydroxide should precipitate lead-2 hydroxide. And so let's see what this comes out to here. What color do you think lead-2 hydroxide is? White. White PPT. Now, watch it. If I add more hydroxide, I expect I'm going to max out the PPT. So I'm going to just continue adding hydroxide to this. And so I got a nice white PPT there, right? So I want the PPT to settle to the bottom of the test tube. And when the PPT settles to the bottom of the test tube, then I should have a nice colorless layer of what this is going to form. Sodium acetate. And so sodium acetate should be a CCS, and then I should have my white PPT on the bottom. But my white PPT didn't settle. In fact, my white PPT, can you see it? My white PPT disappeared. Why is that? Too much hydroxide. But what's the problem with too much hydroxide? The problem is this. There's one more reaction that I want you to do the observations for, and that is there's a competing reaction occurring here. Sometimes we get competing reactions. So, for example, I asked you to do two equations for the first one. What was that first one I wrote on the board? Do you guys remember? It was iron 2 sulfate plus silver nitrate. Remember this one? Iron 2 sulfate plus silver nitrate gave you what for your observations? We had two competing reactions. Did both reactions occur or just one? And if just one occurred, which one was it? Both of them resulted in a precipitate. Do you guys recall the difference in the precipitate? I said one is going to be white, the other is going to be black. So what happened?
They canceled each other out.
Well, did both of them occur so you got some kind of mix of products? Or did one occur first, followed by the second one? Or did just one occur and the other one didn't? What did you get for your observations? This is actually the critical one here. This is the one I really wanted to know about. Well, actually I wanted to know about all of them, but this one. Well, anyway, think about that. Now, going back to this one, this is the same reason. Some of you got the baby blue precipitate, which was copper 2 hydroxide. That copper 2 hydroxide disappeared. It's the exact same reason why this happened. The reason why this happened is because of a Lewis acid-base reaction. That was a competing reaction. And so the same reason why this went to a deep blue solution is because we had a Lewis acid-base reaction, which I didn't tell you about. In fact, I haven't even talked about Lewis acid-base reactions, right? And so what we want to do when we want to predict reactions is we have to look at all the types of reactions. All the types being metathesis, acid-base, but in acid-base there are two types, the Bronsted acid-base and Lewis acid-base, and then redox. The problem is I haven't said anything about Lewis except, I did CO2 in water, I did calcium hydroxide in water, and that was it. The problem with Lewis is it's a bit more complicated, and those types of Lewis acid-base reactions are discussed much more in Chem 1B. And so what we have to do is we have to keep in the back of our mind we aren't factoring in potential Lewis acid-base reactions. So that's one type of reaction that's missing. If we covered that, then we covered all bases, everything. But we're just going to have to wait until Chem 1B, otherwise it's too much to talk about right now for Chem 1A. So that's about observations and reactions, and so this, this is probably the first experience for a lot of you for taking chemical observations. So don't worry about this too much here. But in the future, you have to think about how you record your observations. Are your observations detailed enough, or are you going to have to do like me and repeat, experiments? Do you want to go back and repeat experiment 18? Probably not, but you might have to if you didn't take adequate observations. Okay. Well, anyway, that's it. So let's talk about today's experiment after a break. So we'll take a break and then